Good morning, everyone. Thanks for coming to my session. Like you, I'm a developer. I'm really passionate about developing. I like writing code. What I don't like is writing plumbing code over and over again. I really like to spend my time on cool stuff like creating nice, clean architecture, optimizing my code, finding a clever way to solve a problem. So that's why I proposed this session, and I'm Davide Mauri. I will be here this morning with you to discuss about how you can increase developer velocity with Azure SQL Database, moving from the data you have in your database into API. So the agenda is pretty simple. We start with a common scenario. I created a kind of a sample that I think you can relate, even if you will be using public transportation data. And then we see how Azure SQL can help us to create a very simple, efficient, and scalable architecture. And of course, talking about scalability, we also see how we can scale for the future. So we start basically from an idea, and we'll make it a reality able to handle any kind of workload. So let's start with the common real-world scenario. So let's say, in my example, but again, I'm sure you can relate with what I'm saying, that in our company, be it a startup or an enterprise company, we have a new project that we want to build. And this project, in this sample, aims to disrupt the public transportation market. And why I choose public transportation data? Because public transportation data is available in almost every modern city. For example, Seattle City allows you to download and see in real time data about where the buses are and all the public vehicles that they provide you to move around. And this comes with some challenges. Like, for example, you have a multi-format, multi-source challenge, because data about vehicles is available in a structured format, so it's probably perfect to be stored in a table. But then you have data coming from vehicles or a bus stop that is coming in as a JSON format in a very dynamic format, I would say also, typically JSON. So you also have the need to make sure that you can handle these two formats nicely together. Also, you need to handle the data in different ways. Again, this is very common, because when you want to show the user profile on the application you are going to build based on the data, on this public transportation data, you just want to access very quickly single item, single row, single document. But then, since you need to understand and predict what is going to be the average delay, if there is any traffic jam, you need to quickly aggregate data over time. So you need to be able to do aggregation quickly. And of course, since we are talking about moving people from one place to another, you probably need to find a way to provide the shortest path between 2 points, taking into account also, again, traffic jam, vehicle size, and properties, and so on. So kind of a graph model approach would be nice here. So different data, different usages. And of course, my boss always come to me and say, hey, this is a great idea. We want to be fast, agile, so we need to ship everything in 3 months because we want to ship the product, get the feedback, improve the product, ship it again in a very nice and modern way. Which means that as a developer, I need to apply or follow a kind of an agile approach because I want to be able to improve my application over time as we get the feedback. And so I need to be able to have a CI/CD pipeline, inner and outer loop, well and properly done, and integrated with my database too. And of course, I also want to be able to scale, because I believe that my application will be super successful, because how many people use public transportation every day? Millions, right? So I want to be able to go from a very small prototype and be able to scale up to 1 million users. And of course, making it also economically viable, because I want to make money on this, hopefully. So the entire solution must be scalable and efficient. And last but not least, we have a security issue here, because our application will handle very sensitive data, not only my personal information, but also the path I use to go from work to home every day. So we need to be able to make sure that the application is secured, but also auditable, and with a proven track or log that shows that data has been not tampered with or altered in any way. So we need to take into account all of this stuff. Now, here's my solution for you, and if you have any question, make sure that you use the QR code there. You probably know the drill already, and my colleague and friend Drew will be happy to help, especially if you are watching this online. Because I'm going to show you that this solution can be done with any language you want. I don't want to constrain you or your team to any language or any framework. Use anything you want to build your front end and the back end or the middle tier, whatever. But for the database, you use Azure SQL Database. Now, when I say that, yeah, of course, this may be obvious because I'm from the Azure SQL product group. And you may say, but you know, man, when I ask my developer to start to use SQL Server or Azure SQL Database, they start to scream in pain because installing it is so painful. Like you have to download, install, it takes a lot of time. Well, not anymore. Because with the new release a couple of weeks ago, SQL command, you can install and download, install, and use SQL Server and thus Azure SQL on your machine in probably a minute. You just do SQL command, create MS SQL. It will download the image and install it in a container. That is the only requirement that you have to run on your machine. Then you do SQL start MS SQL, the container you just downloaded and installed. And then you do SQL command open ADS. It will open Azure Data Studio and connect to the database you just created. Super simple, super fast. In 1 minute, everyone on any platform is ready to use SQL Server. And remember that the SQL Server version, the developer edition, is free, so anyone can use it. Now, after you have opened Azure Data Studio, you need to start to import some JSON data, because that's what I said. It's coming from the Seattle City, for example. So I want to be able to quickly import this data and start to build a prototype. Now, you know that this used to be painful, especially if I'm not super expert in T-SQL already, the language the SQL Server uses. So let's say you have this kind of data, right? Well, Copilot can help you to import this data, create the right table, query the JSON data that you are using as an example, super easily. And Copilot has been released yesterday for Azure Data Studio, so you can just download it and start to use it. Actually, let me show you how you can use it. So what I have here is my sample data, right? I just added as a comment. This is exactly the same data I showed before with data about vehicles and position. Let me create a table. And, well, let's call this table vehicles, positions, data. Yeah, OK. And then, oh, that's cool. Then Copilot inferred the data from the sample and started to provide me some help. Now, this is not the table I like, because this is a Copilot. It's helping me to be more efficient. It's not replacing me. That's super important, right? So I probably want to refine this table a bit, because, yeah, I don't like to have like these columns, and latitude and longitude probably I will not store it in a float. Timestamp, I definitely want to keep it. So let's move to a decimal here. And yeah, 9 of 6 will be nice. And then the same for the latitude. And what else we have? Yeah, label, I don't need it. The route ID, it's probably an integer. The vehicle ID, it's probably an integer. Direction, actually the vehicle ID is a varchar. Direction is an integer, and the trip ID is an integer. I will leave the ID as a varchar, and I will make it a primary key, and I want to make it non-clustered because it's not really a number, it's just a string. And I also want to save the information about the stop that may vary, based on the stop that the bus is stopping on, in some JSON format. So here I'm creating a new column called stop info, where I store. Oh, that's cool. It automatically helped me to make sure that this JSON is JSON, and I will store in this column additional data that I don't want to store as a structured data. OK, I created my table. Now, let me bring in some real data, not in a comment. So I have this JSON data that I want to save in this sample, or store in this sample variable. Perfect. Now, let me kind of collapse this so we have more space. Nice. And now let's start select from, oh, again, Copilot understood that the sample is a JSON format, so I need to use OpenJSON. And let's see if it can, yeah, it can help me to immediately extract the structure, and it's able to infer that I have to do vehicle.trip.routeid to get the data that I want. Now, I need to get some additional data from the vehicle, so I will call this column out of this JSON source data, and let's see if this works perfectly. First try, I can already read the data from the JSON. Now I want to add this JSON into my table. And I need to transform this a little bit, because in my table I have stop info column, not the source data. So again, Copilot is helping me, and it doesn't know about the stop info column because it's only in my mind. It's only in my mind how I want to transform the data that goes from the JSON I have into the column I need. So stop info, here I will start to use the new JSON object that we just added in SQL 2022 and Azure SQL that helps me to create a JSON object easily. Stop ID, I need to help him. The stop ID property will come from the JSON value, stop ID, nice, another new feature here. And then it learned that the current stop sequence is basically extracted in the same way as the other, just using another property. So it helped me to be super efficient. And here we go. I have my sample data in my table, and I can start developing. And this has been done in 5 minutes or less. So this is super, super nice because it helps me to be efficient, right? Now, that's cool. JSON data, you probably know, was already supported in SQL Server 2016 and after. We have the for JSON operator, OpenJSON, and other functions that allows you to manipulate JSON data. But so far, JSON data has been stored in a string, basically, a varchar. In SQL 2022, we improved the function that allows you to manipulate JSON data with, for example, JSON object to create an object, JSON array to create an array. But the important part is that now I am announcing, and today the post has been just released, that you can join the public preview, the private preview, to start to use a new data type that will be available in Azure SQL and SQL Server that will allow you to store JSON more efficiently as a binary data, but still use it as a JSON, which it will be the building block on which we will create more feature in futures, but you can start to use right away today. Because, for example, now your table, instead of storing JSON as a string, can store JSON as an optimized data type that is handling JSON. So make sure that if you are interested, you go back here, aka.ms JSON preview, and register for the private preview. This will land soon. Thank you. Thanks. You see, the PM that is managing this feature will be happy to hear your clap, so thanks a lot. Now, besides JSON, we also need to navigate a complex relationship, right? Because we said we are keeping transportation data. So we probably want to have a graph data model to manipulate edges and vertex and places where we want to go. And this is exactly what you can do already with Azure SQL. You can create a graph model in SQL using, again, the create table command with just an additional option as node or as edge. And then you can use, for example, shortest path to find the shortest path between two nodes across different options. So that's great. We can use Azure SQL. We don't have to move data out of Azure SQL or SQL Server to do these complex computations. Then, of course, we also want to aggregate a large amount of data because we have all the historical information about the bus and their performance and the latency and whatever. So we probably need to quickly aggregate a lot of data. That's why a nice column store-oriented database will be super nice. Well, guess what? Azure SQL Database and SQL Server has the column store since years ago, and we are constantly optimizing it over and over again. So, for example, with a column store, a row is not stored as a row, which is perfect when you have to access all the specific data of that row, but it's stored, all the value in a column are stored together. So when you need to aggregate over data, for example, or time, or latitude, or longitude, everything is super fast because we can compress a lot. So on the same table, you can have both the column store that is great for aggregating data super quickly, and the row store that is great to accessing the single item super quickly. So you don't have to choose between one storage or the other. You can have both on the same table. And as I said, with the column store, we can do some nice trick because it's very likely that the data in the same column is similar to all the other data in the same column. So we can compress a lot, and we can use vector computations to speed up processing of aggregation. So we really do basically use the same operation that are used by 3D games engines to speed up calculation on vectors. And this, as you may probably already understand, can help also in doing open API calculation on vectors. And I will be writing a blog on this very soon, so watch out for that. Also now the column store is available as an ordered column store, which also improves, again, even like time series analysis. And in general, column store, if you haven't started using it, you should really start, because it's great for everything that is analytical, reporting, HTAP, hybrid transaction, analytical processing, real-time analytics. I'm not kidding, it can speed up your performance by 100%, right? Of course, it needs to be the right use case, but I've seen it with my own eyes, improving performance by 100%. It's more likely 10%, 20, 30%, but even, sorry, not 100%, but 100 times faster. Yep, 100% is okay, but yeah, not impressive. 100 times faster, yes, woo, man, that's it. Now, why I'm telling you this? Well, because all these different models are together in the same engine. So, for example, a company like BKW that needed to model a graph of network of energy providers or energy places where they provide energy, they decided to move from a NoSQL database back to Azure SQL, which is relational and multi-model, because they could use the column store with JSON, with the graph. Yes, you can create JSON into a graph and put it a column store on top of it. So you can mix and match and use everything together. That's the work we do. It's not only creating the feature for you, but make sure that those features work seamlessly together, so you don't have to move data around and use 3 different databases that you have to learn, maintain, and pay for, and so you can just be more efficient. That's why I love being in the Azure SQL group, because I think we are really doing a great job to improve efficiency of developers. Now, since you are a developer, you care relatively enough about what I said, but what you really want is API. You don't care about tables or stuff. Yeah, I mean, okay, you have to live with it, but you really want API. Why? Well, because you are creating a front end, you are creating a mobile application, and all you want is an API that you can call and get JSON back. Well, that's exactly what we need to do over and over again, right? Now, not only we need to do over and over again, but for every time I create my backend to take my data in my table and expose it as a REST endpoint or a GraphQL endpoint, I also need to think about pagination, filtering, ordering, selection of field, performance. I am implementing a retry logic correctly. I am adopting the right best practices. All this kind of stuff, which is boring. Because it's nice the first time you do it. The second start to be meh. The third is like, man, again. But still, if you have 100 tables, that's what you have to do, right? Well, maybe not anymore. Because with Data API Builder, it's an open source tool that we released 1 month ago. You can just install it, do dub init, because it also comes with a CLI, initialize which database you want to use. We support, of course, Azure SQL and SQL Server, but also other databases in Azure, like MySQL, Postgres, and Cosmos. And then you do dub add, and you define what table, view, or storage procedure you want to make into a REST and GraphQL API, with all the bells and whistles, pagination, filtering, and everything. Then you do dub start, and that's done. I know it's hard to believe, especially this time in the morning. Maybe you haven't got coffee yet, but let me show you, because that's exactly what I want to see, what I want you to see with your own eyes. So I have my sample here, and I am on your left, yes, you have my console, and on the right, you will see what happens to my solution. So I just need to install the API Builder. Of course, I already have it installed on my machine. And yeah, the latest version is 0.7.5. And I want to expose the routes table. Oh, the stop. Let's use the stop table, yeah. So I want to expose the stops table. So this is just a regular table, right? Select from stops. These are all the stops that are here in Seattle and close to Seattle. Or maybe I have a view where I just want to show the position, where I want to expose the position data, because for each vehicle, I will have the latitude and the longitude, or I have a stored procedure. Now, why I want to use a stored procedure in this case and not a view or a table? Because in the stored procedure, and let me show it to you, I can pass latitude and longitude and ask Azure SQL what are the buses that are close to this position. Why I can do that? Because inside SQL Server and Azure SQL, there is a geospatial engine also, in addition to the graph, the model, the document model, and the relational engine. So I can ask, given this position, what are the buses that are closest to me within a radius of X? 50 miles, 30 miles, whatever you want. So I need to create a storage procedure to push the calculation to the data, because so I don't have to move the data out, which is going to be expensive. OK, so that's what I want to do. Publish a table, publish a view, publish a storage procedure. So I just need to do dub init, specify the database file, the connection string, and I can also refer to environment variables if I don't want to put the connection string in clear text in the configuration file. And now I'm using a development mode because in this way you will see all what's happening behind the scene. After I did the dub init, dub config has been created for me, and it's just a configuration file, a standard JSON configuration file, where you define a bit of options for the runtime, but the most important part is the entity side. Entities is what is exposed. By definition, of course, for security reason, we don't expose anything unless you tell us to do so. And how you can tell us to expose something? Dub add, name of the entity you want to expose, table, permission. In this case, I'm saying anyone can access anything. So star means the create, read, update, and delete operation that you are normally using and creating in CRUD API. And then where is the path where this table will be available as a REST object. Nice. So this is basically, you see that dub CLI just updated the configuration file. Now I'm adding the view. I'm calling it position. And a view is basically a table, as you know, right? So I'm just adding a view using the same approach I did as a table. But I want to make this view available as a read operation, as action, as we call it. And again, the path at which this view will be available will be position lowercase. Now let me clean up and also add the storage procedure. Storage procedure is a little bit more complex because you also have parameters. So what parameters you want to allow to be used, and if someone doesn't specify a parameter that you need, what is the default value? So that's how you specify the parameters, names, and the default values. Perfect. And the permission star, in this case, of course, doesn't mean create, read, update, or delete, but means that someone can execute that storage procedure if they go to the get bus near position endpoint. And for GraphQL, typically for storage procedure, we generate mutations. But here I want to use a query. And I want just to stop a second here to make sure that I tell you that this configuration file allows you to configure everything. We created Data API Builder, so the resulting API would be, or would look like exactly the API you would have written by yourself. So we don't constrain you in special names or special routes. You can decide whatever you want. I did dub start, then I can just go to my local endpoint that has been created for me, and here I have my GraphQL playground. This is there because I'm in developer mode, and that's it. I can just query my data, and that's it. That's my storage procedure running as a GraphQL query and returning JSON data. I can, of course, use all the GraphQL options that I have, like adding or removing fields. I can filter. This is the storage procedure, and let me actually add another field here. So we also generate the full GraphQL schema, so you can also have IntelliSense. And here you go. That's my storage procedure running. So in, I don't know, 1 minute, I just created my endpoint. And as you can see, behind the scene, we even show you what's happening. So these are the query that we actually create and run when you execute a GraphQL query. Now, maybe you are interested in REST, not GraphQL. So we also support REST, this is with the latest version, and we also added support for OpenAPI Swagger. Here's the table that we published, and with all the methods you can use, with the description of what you can get. And those are your tables and views and storage procedures. So super easy to get your data from your table into your API. You don't have to write this plumbing code anymore, because that's what we have done for you. And Data API Builder, as you can see, is just a .NET application. Now I'm executing my REST query from Visual Studio using an extension. Here's my data about my storage procedure, for example, here. So Data API Builder can then be deployed as part of a static web apps, because we integrated with static web apps, or you can just deploy it as a regular .NET application, maybe in a container using app containers or app service or wherever you want. And it's open source, so you can even use offline just to make sure that you can nicely work offline and then move everything to Azure. So this is also pretty nice and helpful to improve the performance or the velocity of your coding skills. Now, everything is nice, but it will not be that useful if you cannot put everything I show you in a CI/CD pipeline. Well, Data API Builder included can be put into your CI/CD pipeline. So with Azure SQL, you can create a SQL project, you can add Data API Builder, you can put it in your CI/CD pipeline and deploy it on Azure using GitHub Actions or even Azure DevOps. So you really have a full comprehensive support for modern application development using Azure SQL, again, from the table to the API. Now, talking about architecture, this is what I would have had to do if I were not to use Azure SQL. Because, yeah, I have my website, I have my mobile app, I create a REST backend, I create a GraphQL backend, then my REST backend and GraphQL backend will probably communicate with some microservice to do the geospatial query, right? But then my data is coming in as JSON, so I probably need to use a document database. But then I need to move the data into a graph database because I need to find the shortest path. Then I need a column store database because I want to aggregate data over time. And of course, all these three databases need to be kept in sync. So I also need to write a microservice that moves data between databases and make sure that everything is in sync, which it's not super exciting and fun to write. It's usually where there's a lot of hidden complexity, right? Instead, and I'm not saying this is a bad architecture. Maybe you have to go to this architecture at some point. Because you need some special or specific usage that only that specific graph database can provide you. But you can start from a much more simplified architecture. Because you create your own website with the application framework that you want, with the language that you want. You create your mobile application with the language that you want. You use Data API Builder, which is, by the way, a stateless application. It's completely stateless, so it can scale out as much as you want. And you can use Data API Builder to serve REST and GraphQL API. And then you have the Azure SQL database behind the scene that helps you to get relational data managed, document and JSON data, graph data, column store. And you can put all of this together, and it's very easy to ingest JSON data and elaborate it and process it so that you can provide all the features that we mentioned. So we're good because that's what we need, like the ability to simplify your architecture. Now, the point is, will that scale? That's a very good question. And what I really want to highlight here is that Azure SQL can scale as much as you need. Because especially with a couple of improvements that I will discuss in a minute, you can really scale up and out as much as you need. And the interesting part is that you can still use whatever you were used to use, like the CI/CD pipeline that you use, the SQL project that you're already using. And you don't have to move to another database or another place or another whatever. You don't have to re-platform your solution to make it scalable. So for example, with Hyperscale, you can take, which yesterday someone came at the booth and asked me, is Hyperscale another or compatible with SQL Server? I want to make this super clear. Azure SQL Hyperscale is the same engine of SQL Server and Azure SQL. So Hyperscale is not a compatible something, is the same engine. Whatever you do on your SQL Server or Azure SQL Business Critical or General Purpose, it will work on Hyperscale. Because Hyperscale is a re-architecture that we did behind the scene to make the service super scalable so that it can go up to 100 terabytes of data. It can scale up to 128 vCores. It can have up to 30 secondary read-only replicas, so you can have a huge amount of power if you need. But it's still the SQL Server you use and love already, and it supports everything that I just mentioned, literally everything. There is nothing that is not supported of the thing I mentioned before. So Azure SQL Database Hyperscale is the way to go if you want to start small and scale as much as you need. Now, you may ask me, yeah, man, I look at this is expensive. Yes, you're right, because that's, scaling is not a cheap thing, but we announced recently the public preview of Hyperscale Serverless, which means that you are only paying for the second, and you can define a minimum and a maximum range of the vCore, and we will automatically scale up and down within that range to make sure that we can sustain the workload you are throwing at us. But when there is no workload, you're not overpaying for having, like, I don't know, 8 cores sitting there doing nothing. So Azure SQL Database Hyperscale Serverless is probably what you want to start to look at to make sure that you can start small, pay for what you use, and then if you need, you can throw like super aggressive workload, maybe 1 second per day, and we will happily handle that peak, or you can just scale up more nicely if you have a growing workload. And again, you can always move then from one tier to another. Say at some point you don't need the serverless anymore because you are big enough that you always need, I don't know, 16 vCores, and maybe you decide that it's worth for you to pay for just that 16 vCore, and that's it. You don't want to have the second billing or whatever. So you can always move, but my suggestion is start with the serverless because it's perfect for development and for helping you to ramp up from a small kind of workload to a bigger one. Now, something we announced yesterday are the elastic pools. Let's say that this application is super effective, and I sell it not only to the Seattle city, but to all cities in the world. And of course, I need to scale in terms of instances that I need to execute and run. And so I'm kind of an ISV. I'm becoming an ISV. So I would like to pay for a number of CPU and use that number of CPU across several databases because, yeah, Seattle is absolutely killing it with the application, but maybe another city is just starting and it doesn't need all that power. So I want to kind of balance my investment across different instances, and that's exactly what the elastic pool allows you to do. So you can have a pool of Azure SQL Hyperscale, where you can put up to 25 databases, and you can share the cores and the memory across this pool so that you can kind of manage different workload for different instances of the same database. Then, oh, actually, let me show you something. I didn't remember I had this, but let me go here. And yeah, so this is where you can start the Hyperscale serverless. So here, you just go to the Hyperscale page, and you have now the ability to select provision or serverless. Of course, serverless means that we are auto-scaling for you, and everything is billed per second. Now, what you can do is, of course, set the max and min vCores that you want to use. So we will scale within that range. And in this case means that the minimum you will ever pay is 2 vCore, because at the moment, serverless doesn't support complete pause. So this is the minimum you will be paying for, even when there is no workload, which is unlikely for this application I'm building, because even at night, people will be taking public transportation. And here, you can see how we scale up given the additional workload we are throwing in. So the moment the workload starts, and the chart on the top shows the workload, it's a batch request per second, so it's around 20,000. The moment the workload starts, we start to scale up the CPU very quickly, immediately, right? And the second chart is the green one, the one that I'm showing right now. And of course, we also scale up the memory. Now, the memory takes a little bit more because we want to make sure that we don't overuse the I/O that we have, so the memory scale up a little bit slower. But then at the end of a few seconds or minutes, everything is up to the maximum because the workload is sustained. And you are built basically taking into account both the memory and the CPU usage, right? And this is a chart I already prepared with some workload spike. And as you can see, if you have the workload spike, well, if you don't have the workload spike, everything is at the minimum. In this case, 2 vCore. That's the minimum we choose. But then, as soon as the workload spike starts, you will see that we ramp up the CPU and the memory goes down slower because, again, we want to make sure that we avoid the cache thrashing because that will overload your I/O. So we are a little bit conservative in kind of removing memory from what you can use. And the billing goes down as the CPU and the memory together goes down. There is another spike. We immediately increase the CPU, increase the memory, the buffer pool basically that you can access to as soon as possible, and then again move back slowly to make sure that if there is another workload, another workload spike just close to the next one, you don't have an empty cache, which again will trash your IOs, right? So we are trying to balance between handling the spike and making sure that you don't overpay for everything. So that's it. That's our application. It's done. We did basically everything. So we created this application that has the most varied options of data. It allows you to aggregate data, to calculate shortest path using graph model, to store it into an Hyperscale database so that I can start with a few gigabytes today and arrive up to 100 terabytes. I can create read replicas if my administrator wants to start to run the super complex reports. And in general, let's say that at some point my architecture become more complex, right? So you can see I need to add the analytics with the beautiful fabric that we just released. I want to start to push events to event tabs to make it even more scalable. I want to start to use React to give real-time update. I want to use any front end. I want to do the telemetry. So it is very nice architecture. As you can see, seems to be complex, but there is one thing in the root, and it's where everything is kept simple, is Azure SQL Database. So Azure SQL Database can really be at the root of your application and help you to grow organically so that you grow as the complexity grows. You don't just have over-complex architecture for no reason, right? So I really love the ability to use more stuff in Azure SQL and grow it as my complexity and business need grow. Here you have a lot of resources for everything I mentioned. You have a link to the GoSQL command, JSON in SQL, column store, graph models, and of course the Data API Builder. Data API Builder, aka.ms/dub. This is where you want to go and download the Data API Builder so you can use it on your machine even right now. It literally takes 1 minute to download. For Data API Builder, you also have already full end-to-end solution. So beside the sample that helps you to say, OK, I want to expose this table as a REST endpoint, we already built, for example, a very famous application that I like a lot. It's the to-do application, where you have your front end and the back end. And that has been rebuilt using Data API Builder behind the scenes. So you can see how it works. Because I didn't mention during my demo, but we also support authentication and authorization. So in Data API Builder, you even have the ability to use a row-level security to make sure that if I log in, I can only see my profile and not yours, right? Which is something you would normally do in your API. So make sure that also to check the sample because they provide you a full end-to-end overview of Data API Builder. And with that, I have concluded my session. So if there are any questions, I'm happy to answer right now live, or if there are any questions from the friends watching online, I'm happy to answer. Oh, here we go. Thank you. So Rory asked, we have tried the automatic API over SQL approach before with limited success. Why DAB is different? Well, I honestly don't know what you tried before. Why DAB is different? I think we spent the last 2 years working on it and making sure that it's done exactly as a developer would do it, with all the configuration possibilities that you may wonder. Like, I'm super picky about how I name my routes in REST, and so we allow you to even select if you want to have singular or plurals. We automatically generate the name, but you can choose what name you want to override if you don't like the name we generate for you. So I think it's kind of a developer approach that we use that will make it successful, and also it's open source. And by the way, for example, the fact that it's open source helped us to really work closely with the community. So the GraphQL engine, we didn't reinvent the wheel, it makes no sense. We are using Hot Chocolate, and the creator of Hot Chocolate has been working with us to make sure that we use the best possible implementation and best practice when doing GraphQL with the Data API Builder. And so that's definitely something that I think we never did before, and we started doing right now that will help to make sure that that is different. Anyway, just go try it and let me know what you think. There are any samples on how you put security in front of the API? Yes, if you go to the examples, and I actually recording videos also on YouTube to show you how you can integrate with Azure Active Directory, or even with static web apps, because we integrate with static web apps with Twitter, GitHub, Facebook, whatever. Because at the end of the day, we use Auth2 as an authentication kind of protocol. So once you're authenticated, you present us a token with your claims. The claims are available to you with a kind of expression language that I didn't show in the demo, but is available when you expose your table, where you can say, hey, whoever has logged in can only see the rows for which the email is equal to the user email in the claim. So you can really do row-level security. If you're using Azure SQL, as I would recommend, you can even use the row-level security natively integrated in Azure SQL, because we allow you to inject into the session context the claims. So you can create really row-level security using whatever is available in the claim on the database. So that should help you to make sure that your API is as secure as you would have created it. Any other question? Otherwise, I'm perfectly on time, which is great, and probably my first time. So. OK, thank you so much.